Hey guys, welcome back. So what we're looking at today is 14.1 line plots. So how can you organize data using a line plot? So a line plot shows data along a number line. Each X represents one number in the data set. An outlier is any number that is very different from the rest of the numbers. The table shows the average lifespans of certain animals in years. Make a line plot and organize the data. So we have the kangaroo, chicken, fox, cow, wolf, deer, and black bear. We've got 7, 8, 9, 10, 10, 10, and 18. So we want to make a line plot for this. I'm trying to find some space to do that. We'll do it up here. So we've got our line. The lowest we had was 7. And then we go 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we have the kangaroo has a lifespan of 7 years. The chicken has a lifespan of 8. The fox has a lifespan of 9. So each one of these gets an X. Cow has a lifespan of 10. The wolf also has a lifespan of 10. The deer has a lifespan of 10, so we put 3 X's above the 10 to represent each one of those. And then the black bear has a lifespan of 18. So what is the most common lifespan among the animals? So the one that has the most, that would be 10 years. The longest lifespan, well, that'd be this one out here, the 18 years. Our shortest was the 7 years. And our outlier was definitely that 18 years. Everything else was between 7 and 10. All right, so here we have a line plot already created. How many giraffes are 14 feet tall? So if we look, we've got 2 X's, so that means there would be 2 that are 14 feet tall. What's the most common height among the giraffes? So look for the one that has the most. That'd be 15 feet. How tall is the tallest giraffe on the line plot? That'd be our 18 feet. And is the number 18 an outlier? So there is a jump in the data. We go from 14, 15, 16. We skip and go to 18, but we have 2 values. So could be. Because it's not very far and because there's more than one at the outlier, sometimes we wouldn't consider that an outlier, but we could if there aren't any others. So which animals had a lifespan of 10 years? So going back, we had the cow, wolf, and the deer. So cow, wolf, deer. A mouse has an average lifespan of 2 years. If you included this information on the line plot, how would it affect the line plot? There would be 2 outliers. Just there would be 2 outliers because we'd have the 2 way down here, and then we'd be all the way up here with our 18, and then we have our 7, 8, 9, and 10 all right here. So it'd be very spread out. How can we use line plots to organize and represent measurement data? So the pets in Paulina's pet shop have the following weights. The dog's weights are in pounds. How can we organize this information in a frequency table and on a line plot? So frequency table means that we are going to make a table to represent how many of each there are. So the smallest value we have is the 2 1/2, and it looks like we have 1, 2, 3 of them. We have 6 is our next value. We've got 1, 2 of them. Let's see, 7 1/4, but there's just 1. We've got 11 1/2. There's also just 1. And then we've got 4, 12 1/4. So 12 1/4. There's 4 of them. So this would be our frequency table. So we'd have our data point plus how often it occurs. So then we come over and we want to make our line plot. So here would be 2. This would be the 2.5. So we'd have 1, 2, 3 here. We'd have 3, 4, 5, 6. And we'd have 2. Here would be 7. Would be 7.25. So we'd have 1 because 7.25 is the same thing as 7 1/4. Then we've got 8, 9, 10, 11, 12. There's 11.5. We've got one of them. And there would be 12.25. We've got 4. So sometimes figuring out how to write out the number line is a little complicated, being as, we've got some fractions in there, we've got whole numbers, so making sure that we can write it as best as possible. But the frequency table helps us organize this and see, okay, how many do I need to have for this number? How many do I have to have for this number? And so it makes it easier rather than if we had this big table up here and we had to go, okay, 1 for 7 1/4, 1 for 2 1/2, and we're bouncing around everywhere. It makes it easier having that frequency table. Draw a line plot to represent the data for the weights of the pumpkins in a crate. So we've got our line. Here's 3, 4. This would be 3 1/2. And we've got 2 there. And that's 4, 5, 6, 7, 8. We have 5 1/4. So this would be our quarter. We've got 3 of them. We have 4 7s. And then we have 1 8 and 1 8. So that would go here. So how many pumpkins are in the crate total? So we've got 2 plus 3 is 5, plus 4 is 9, plus 1 is 10. So there are 10 total. We can also count the X's. What values do you need to show on the line? Well, we need to have the 3 1/2. We need to have the 5 1/4, the 7, and the 8 1/8. So we need those values specifically to show up on this. So your keyword for this lesson is line plot. Line plot. If you guys have any questions, feel free to ask. Have a wonderful day.